We have also seen ROM as an implementation of any combinational circuit. The one example we have taken here, this combinational circuit receives a 3-bit number and generates square of the number. Okay, like this we have seen yesterday. Okay, the A0, A1, A2 are the inputs. See here we are applying a binary number. Okay, 0, 1, 2, 3, 4, 5, 6, like that. So outputs are 0, 1, 4, 9, 16, 25, 36, 49, like that. Okay, square of the input number. So we are implementing this combinational circuit with the help of a ROM. What is the design procedure here? It is simply to provide the ROM truth table. So from the observation of the truth table, we have seen that B0 is similar to the A0 bit input A0 bit. So A0 can be connected to the output B0. One point. Another point is that the output variable B1 is always 0. So B1 also can be connected to the logic 0 state. So the only variables which will take different values are B2, B3, B4, B5. So only 4 output variables can be considered here, like that. So B0 is fixed as A0, B1 is fixed as 0, like this. So ROM. Now what kind of ROM is required? A ROM with 4 output variables and a ROM with 8 memory locations here, because 8 inputs, no, 8 inputs, so we have 8 different data elements. Okay, so 8 by 4 here. So like this is the block diagram. I have given some small exercise based on this. Those who want to have good understanding, please try this by developing the internal logic diagram. That is left as an exercise to the student. If anybody is having doubt, they can approach me or they can send me their internal logic diagram for my verification. Okay. Okay. Next, another programmable logic programmable array logic. We will see. Okay. This ROM is we have different types of ROMs available actually. One is programmable. Programmable ROM. This is PROM. We'll say that PROM. PROM. Another is erasable ROM. Erasable. Programmable read-only memory. This is EEPROM. And another is electrically erasable erasable programmable read-only memory. This is called EEPROM. So these are different versions. Programmable ROM means first I told this ROM is available with all this. For example, in 32 by 8 ROM, in 32 by 8 read-only memory, we have all the fuses available. So whatever required fuses, whatever fuses are required, that can be programmed wherever there are connections required. That is called it's a hardware programming. It's an hardware procedure. So fuses will be kept intact, and at other places for logic 0 means a fuse will not be there. Fuse will be blown. Okay. So fuses will be blown by applying a high voltage electrical pulse. So here this cross marks means fuses are available. So like that. At other places, fuses are removed. So this procedure is called programming the ROM. Okay. So programmable read-only memory means during the manufacturing process, all the fuses are available intact. Okay, intact means fuses are available. So here, for example, we have 8 OR gates, and here we have 32 outputs of the decoder. So internal diagram, this what we are seeing is the internal diagram. Between this decoder outputs and the OR gate inputs, we have connections. So like that, here we have 256 connections, right? So in that 256 connections, connection means at every connection we have one fuse. So 256 fuses are provided for the customer, for the user. So user, according to his requirement, he will establish the required bit pattern. Whatever data has to be stored permanently in the read-only memory device, that can be done at the customer point, at the customer place. Okay, in the laboratory. Here customer or user means not the common public. Here the customer or user means is a electronics engineer, is a designer, is the designer. Okay, digital designer. Okay, for that digital electronics engineer, suppose he wants some kind of ROM with a certain kind of bit pattern stored inside the ROM. So that bit pattern can be decided by the user itself. That is what. Okay, that's why this device is known as programmable ROM. So they are available as programmable ROM. Manufacturer will provide in this format, programmable read-only memory. So sometimes at the time of ordering itself, the user can provide bit pattern to be stored inside the ROM to the manufacturer. So he will provide the information in the form of truth table. So the manufacturer will during the manufacturing process, in the last stage of the manufacturing process, he will program the ROM. Okay, so that is one type. Okay, so at the factory itself, it is available sometimes. Okay, so there are finally 4 methods on matter. One is second one is programmable at a customer point. Third one, this is third. This is fourth type. Okay, this is during the manufacturing itself. During the manufacturing the device, during the manufacturing, the ROM is programmed. The ROM is programmed depending upon the customer order. And another is at the customer site. Okay, this is PROM. They are available as programmable read-only memory. We can program. Okay, at the customer's base. Okay, this is at customer's base. This is done. And sometimes once the ROM is programmed, we cannot change the bit pattern. That is the basic fundamental characteristic of the read-only memory. But another type of programmable read-only memories are also available. That is erasable. That means once bit pattern is established, that bit pattern can be, generally it cannot be reversed, but it can be also reversed with the help of ultraviolet, with the help of exposing by exposing the PROM to the ultraviolet light. So the bit pattern can be erased. So those are known as erasable programmable read-only memory. This is third type of ROM available. By exposing the PROM to the ultraviolet light for a sufficient amount of duration, so that the entire bit pattern will be disturbed and reversed. Again, it can be programmed, okay, by the customer. Another fourth type is electrically erasable programmable read-only memory, EEPROM. This is called. So here the ROM, the PROM, okay, the programmable ROM can be erased with the electrical voltage. That is here some difference is there here. So it is an electrical process. Without removing the ROM from the socket, without removing the ROM from the socket, the ROM can be again erasable with the help of electrical voltage. That is electrically erasable PROM. Okay, so this is general information. Don't need not to remember much about this. Okay, that's just for the sake of information, completeness of the topic I mentioned. Next, we will see the programmable logic arrays and programmable array logic. See, all these are known as programmable logic devices. Okay, this is PROM. All these are programmable logic devices, PLDs. Okay. So now, so we have now programmable. Next topic. PLDs, okay. Programmable devices. devices. PLDs, they are called. So there are two types of PLDs available. Now, first step is that already we have seen programmable read-only memory. One is the PROM. I will tell you. One is there are three types here. One is programmable read-only memory. This is one type of PLD, and another is programmable logic array, or you can say programmable array logic. Okay. Programmable array logic, and third one is programmable logic array. Okay. Right. We will see these three types of PLDs. Already you have seen. This was already you have seen. Okay. Programmable read-only memory was already seen. So now we have to see this PAL and PLA. Okay. Now I will take up in a fresh page. Yeah. We have these three types of programmable logic devices. General configurations is being shown to you now. In this first one is a programmable read-only memory. We will see. Okay. First one. First thing. These are programmable read-only memory. So here, and in the second one is programmable array logic. Array logic, and the last one is programmable logic array. In the programmable read-only memory, just to recollect, here we have fixed OR gates. Just a minute. Fixed and array. And array, and it is like a decoder. Okay, it is a decoder. A full decoding of the variables are provided here. Full decoding of the variables means it is like a decoder. Fixed and gates ఉంటాయి కదా, ఇక్కడ చూడండి. ఇప్పుడు డీకోడర్ ఉంది. డీకోడర్ లో ఏముంటాయి? జస్ట్ ఇవన్నీ అండ్ గేట్స్ ఉంటాయి. ఆల్ ఆర్ అండ్ గేట్స్. ఇప్పుడు సపోజ్ 5 వేరియబుల్ ఇన్పుట్స్ అనుకోండి ఫర్ ఎగ్జాంపుల్. సో హియర్ 32 అండ్ గేట్స్ విల్ బి ప్రొవైడెడ్. హియర్ ఫిక్స్డ్ అనమాట ఆల్. సో యూ హ్యావ్ 32 మినిటమ్స్ are generated here. So fixed anamata AND gates. So that's why here in the you have seen already in the programmable read-only memory, in the first stage we have fixed and array. Okay, here decoder will be there. And next programmable or array. Here programmable or array. So here these are programmable. Programmable or array. Right? See here, already explained. See, this array of the OR gates. So the inputs of these OR gates are programmable. See here, wherever there is cross mark, that means connection is provided. Connection is available between the output of the decoder and the input of the OR gate. Some connections are there. So at some places there are no connections. At some places there are connections between the output of the decoder and the input of the OR gate. So here these OR gates are known as programmable. Programmable. These are programmable. Okay, that's why in the configuration, in the general configuration, it is shown like that. Okay, so here these are called inputs. Here inputs, these are outputs. Outputs. Right. Similarly, in the programmable array logic, AND gates are programmable. Okay, programmable AND array. This is called here programmable AND array. You will understand these configurations with the example. Just now I will going to show the example, one example for programmable array logic and another example for programmable logic array. Okay, and here this last stage is fixed OR array. Fixed OR array. Array means a group of OR gates, here group of AND gates. And next year both are programmable in this. AND gates are programmable and OR gates are programmable. So here we will mention as programmable AND array, programmable OR array. Both AND and OR gates are programmable here. So this is programmable logic array, right? Here these are the inputs. These are the outputs. Inputs, outputs, right? Now let us consider one example. Already you have seen the programmable read-only memory. Yeah, programmable means here full decoding of the variables is not available. Full decoding. So now first, what is mean by full decoding? That will come to be known. I am now discussing about the programmable array logic B. Programmable array logic. Programmable array logic. PAL. PALs. Okay. PAL. AND gates are programmable. That means here first AND gates are programmable here. Means what is the meaning of the statement? AND gates are here array of the AND gates. AND gates are programmable. That means full decoding of the variable, full decoding of the variables, of the input variables, okay, of the input variables is not provided. Of the input variables is not provided. That is the mean, is not provided. Full decoding ante ippude ఏంటన్నట్టు మీనింగ్ హియర్ సపోజ్ xy అనేది ఇన్పుట్ వేరియబుల్స్. ఫర్ ఎగ్జాంపుల్ x and y are the input variables. How many ways xy can be decoded అంటే 0 0 0 1 1 0 1 1 అంటే మీనింగ్ ఏంటిది ఇక్కడ x bar y bar ఒక ప్రోడక్ట్ టర్మ్, అనదర్ ఈస్ x bar y, another is x y bar, another one is xy. సో ఇవి ప్రోడక్ట్ టర్మ్స్ కదా, ప్రోడక్ట్ టర్మ్స్ అని అంటాం. సిమిలర్లీ ఫర్ xyz ఉన్నాయి అనుకోండి ఇన్పుట్ వేరియబుల్స్. ఫర్ ఎగ్జాంపుల్ xyz are their input variables, x y Z. ఫుల్ డీకోడింగ్ అంటే ఏమేమి వస్తుంది బాబు? ఫుల్ డీకోడింగ్ అని అంటే ఇప్పుడు ఇక్కడ వీటి ఫుల్ డీకోడింగ్ ఇది 000001011. సో ఫుల్ డీకోడింగ్ మీన్స్ ఇప్పుడు చూడండి ఎన్ని వస్తాయి? 8 వస్తాయి కదా టర్మ్స్. 000110111. ఫుల్ డీకోడింగ్ అంటే 8 టర్మ్స్. అంటే ఎట్లా ఉంటాయి? ఎక్స్ వై జెడ్, ఎక్స్ బార్ వై బార్ జెడ్ బార్. అన్ని మిన్ టర్మ్స్ కదా ఇవన్నీ, మిన్ టర్మ్స్. ఆల్ దీస్ ఆర్ మిన్ టర్మ్స్. సో ఇక్కడ ఏం రాస్తాం? ఎక్స్ వై జెడ్ ఇదేంటి? 001 లైక్ దట్. హియర్ ఎక్స్ వై జెడ్ 010 like this. Here x y z, x bar y z. Here x y z like this. X y z bar. Here x y z bar. X y z. So these are called min terms. Okay. So in a decoder we have, okay, like this. Okay, full decoding means it's a decoder. It's a decoder function. Nothing but a decoder functions. Is it clear? So we will call this as D0. This we call it as D1, D2, D3, D4, D5, D6. Like this, we will denote, okay, the output of the decoder. So for the decoder, the XYZ are the inputs. So outputs are nothing but the product terms. Those are nothing but min terms. So this is called full decoding of the input variables. But whereas in the programmable array logic, we need not to, we will not be provided with full decoding of the input variables. Okay, that means all the min terms are not generated. So one example you will see. Okay. So in the programmable array logic, full decoding of the input variables is not provided. Okay, just like in the programmable ROM. In programmable ROM, we have all the min terms are generated. Decoder ఉంటుంది కాబట్టి ఇక్కడ decoder ఉంటుంది కాబట్టి ఇందులో అన్ని AND gates ఉంటాయి. So full min terms are generated here. So 0, 1, 2, 3, 4 like this, so on, 28, 29, 30, 31. So all these are min terms numbers. Min terms. Okay, 0, 1, 2, 3, all this. అది 0 అంటే ఇగో ఇది 00000. The 1 means 00001 like this. 2 means 00010. It's min terms. Okay, like that up to we see here 11100. That is min term 28. Min term 29 11101. Min term 30 11110. Min term 31 11111 like that. So these are all the min terms generated by the decoder. Right? Decoder is used in constructing the ROM device. Okay, here. So here programmable array logic law, it's not like that. So I will show you one programmable logic array example. It will be like this. Suppose we are considering PLA with 3 input variables. Right. This is A, B, C. We have one bubble and another. Yeah. Here we have some bank of AND gates here. For example, like this. Right. Here AND gates are programmable. Programmable means here. Okay. Just observe this. Here this bubble means here it is A bar. So this is A bar, whereas this is just A. That is mean. That is the meaning. Here B bar. Here just B. The C bar. Here it is C. That means the input variable is applied through a buffer. Through a buffer means as it is, it's like a unity gain amplifier. Okay, that is a is applied through a buffer. Then you will get A, and the same A is applied through an inverter. Then you will get A bar. Okay, so why we will use buffer here? Buffer inverter symbol. This is a common symbol for buffer inverter unit term. This is called. Okay, one bubble that repeats buffer, that repeats inverter, and another is direct one. Okay, normal form. So buffer inverter device. So input variable is applied through a buffer inverter device. So it will provide complement form and normal form, complement form, normal form, complement form, normal form, like that. So Suppose we have connections like this. Suppose we require here the products. Say for example here we have AB bar for example, and here this AND gate is providing AC. Suppose this is providing BC. This is providing A bar, B, C bar. That means here A, B bar. That is, there is a connection between A bar, A and B bar. A and B bar. A. A means here. That is, this is connected with this. A and B bar. B bar means here on connection is there. Next AC. So here A C. C. BC. Next B C. Here A bar, B, C bar. A bar means here connection. B C bar. That means here these AND gates are programmable. That is, they are programmed to generate the required product terms. Suppose in our combinational circuit we have these product terms required. So like this. Next, and these are connected. Okay. Right. We have here two AND gates external. Okay, AND gates are programmable and array of the OR gates. So one example I am drawing. Yeah. Just to see. Suppose here one call cross mark here. Cross mark here another. They are fuses or not. These are all fuses. Next, this is connected to some external OR gate. This can be connected to some logic 0 and logic 1, and similarly another exclusion OR gate here. Suppose there is a connection. Here is a connection, for example. So this is a logic 0. Whereas say this is logic 1. I will tell you the meaning of this one. Okay. So here we have actual function f1. Here we have another function f2. Right. So this is one example for the programmable logic array. So here it is that means this variable is a bar, this is a, this is b bar, b, c bar, c. So like that it is there, right? So here these AND gates, the array of these 4 AND gates are programmable. See, only required fuses are provided. So to generate the products A, B bar, A, C, B, C, A bar, B, C bar. Right. And this PAL is implementing the sum of the products form of a given function, SOP, sum of the minterms. So the sum of the minterms, sum of the products form are. So all the minterms are not being generated here, right? So here, see, if the F1 is, see, the one of the inputs of the exclusive OR gate is connected to logic 0 here. That means here this F1 is appearing in the normal form. And if it is connected to the logic 1 state, see here in the another exclusive OR gate, the second input is connected to the logic 1 state. So here the function is appearing in the complement form. That means, for example, if we have the meaning of this one is, suppose here we have say something P అనుకోండి ఇక్కడ output of this OR gate is P. So in that case F1 is equal to P as it is. Whereas here suppose say Q అనుకోండి, then F2 is equal to Q bar. You see, according to the connection here F2 will be Q bar. Why it is Q bar? Because the second input of the exclusive OR gate is connected to logic 1 state. We know that anything whenever, okay, say P exclusive OR with 0 is given by P only, okay, or P with the exclusive OR the 1 అనుకోండి, P bar వస్తుంది. This is a basic fundamental, okay. Similarly, we know that Q exclusive OR with 0 is Q. Q exclusive OR with 1 is Q bar. Okay, this is general. So this fact is being used here to obtain the final function in the normal form or in the complement form. Right. Here so f is equal to, here f1 is equal to, what is the function here? F1, what are the products of the F1? F1 is given by, as per this, A, B bar plus A C plus A bar B C bar. This is F1. Whereas F2, how it is being available? For more clarity, you can see here. I will write here. This is P. This is okay. Let us say P, and the another one is Q. Q is how do you write? AC plus BC, right? Right. But here F1 is same as P, that is AB bar plus AC plus A bar BC bar, whereas F2 is equal to Q bar. See, Q
Excuse
means
me, sir.
yes.
Sir,
Yes.
English teacher is asking us to join their class, sir.
I will close. Okay, AC plus BC. This is whole bar. So like this. So these are the structure of the PAL. One example I have shown you. We will discuss it. We will continue this discussion later. Okay, I will note down the absentees. Just a minute. Number 61 absent. 7.